So now let's talk about electrons in an atom. For this, we need two models to explain electrons orbiting the nucleus. And the first model is the Bohr model, which postulated that electrons orbit the nucleus and that electrons behave like particles. However, after serious considerations of this model, the Bohr model, which was discovered by a Danish scientist, they find out that this model doesn't explain in details about the behavior of electrons in an atom. So they came up with the wave mechanical model. And the wave mechanical model says that electrons are not like particles, and they don't just orbit the nucleus in a discrete form, but rather as a form of probability or chance of finding an electron in a particular shell. So, like I said earlier on, we need a little bit of quantum mechanics. Or however, they come up with the 4 quantum numbers. And these 4 quantum numbers are the orbital size of the electrons, how electrons orbit the nucleus, and the orbital shape, whether it's spherical in shape, dumbbell in shape, and the magnetic quantum number, how magnetic these materials are, and the spin number, that whether materials have an upward spin or a downward spin. And upon coming up with these 4 models, and in these 4 models includes the Bohr model and the electron in the atoms. This is the Bohr model, this is how it looks like, and this is the probability, the chance of finding an electron orbiting in an atom. So with the help of these 2 models and with quantum mechanics, the Pauli exclusion principle, the Schrödinger equations, all this helped scientists to understand the behavior of electrons and how these electrons are arranged to give us what we call the periodic table. And you can see that in the periodic table, elements are arranged as they increase in the number of electrons within that element. And these elements are arranged into columns and groups. And I advise you do a brief revision about the elements arrangement in the periodic table. And Mendeylev, the Russian scientist, was we call him the father of the periodic table. He arranged the periodic table, the one that we are using. There were a lot of other scientists that we are coming up with theories of arrangement of the periodic table. However, the Mendeleev one was the one we are using up to recently. So I advise you to revise the periodic table and how the elements are arranged in the periodic table, and also how the bonding forces, the attractive bond, the repulsive forces, and the net energies of forces of materials when we bring two atoms together, and how these two atoms behave, how they attract each other, and how they repel. I've made another video on the repulsion and attraction of atoms, and how this works, and I've also made an analogy of this to help you understand the behavior of electrons in an atom, and also the types of bonding, the primary types, which are ionic bonding, covalent bonding, metallic bonding, and also I've moved to explain the secondary bonding, hydrogen bondings, and the mixed type of bonding, and how these bondings are categorized in according to the materials. Like, for example, before we talk about ceramics materials, talk about metallic materials, talk about polymers and composites, and how these materials are as a result of their atomic bonding. And so I thank you for watching this video, and next we'll talk about crystalline structures in materials. Until